circuit built with two operational amplifiers. The input sine wave signal with the voltage of 5 volt and 1 kHz is given. And then the output of the first circuit will be the square wave. And then square wave is given to the input of the second op-amp amplifier. So the first part of the circuit works like a comparator, which compares the input with the reference point here. The first part of the circuit like this, and the reference point is here, which is the output of the voltage divider R1 and R2, V saturation voltage. The input is sine wave. Consider the output of the circuit is currently at the V saturation point. In this case, the reference point can be calculated as Vs over R2 divided by R1 plus R2. So in this case, input voltage is compared with the reference point here. So here we will consider V reference is here. So when the V in, the sine wave is less than the V reference, the output of the circuit will stay at the V saturation until the input voltage reach at the reference point. Once the V input is greater than the V reference, the output of the circuit drop to the negative saturation point, which is negative saturation point. At that point, the V reference is calculated as negative Vs. This is the same here, but it is with negative. So this time V reference will be negative. When the input voltage is greater than new V reference, the output of the circuit will still the same at V saturation point until it reach to the negative reference point. Once the input reach to the negative reference, output will go up to the positive saturation point. In this case, V in is less than V reference, and for this case, V in is greater than minus V reference. So this process continue in cycle that give you the rectangular wave at the end. The frequency of this rectangular wave is the same as the sine wave. So the second part of the circuit is considered as an integrator circuit for the rectangular input. The triangular signal is generated by alternately charging and discharging of the capacitor with a constant current, which is based on the input rectangular signal. This constant current can be calculated by the input voltage and the resistor, which is V saturation voltage of the rectangular wave divided by the resistor, and this is positive and negative. So consider when the input is positive, it creates a positive current through the capacitor, so that derives the negative voltage linearly until negative output voltage V minus, and then at that time the V saturation has become negative Vs, so the constant current minus Vs divided by R3 is generated through the capacitor, and that derives the positive output linearly until it reaches to the positive V output, and then the process repeated continuously.